Eden Park upgrade is for the World Cup in 2011 to expand the capacity from about 45,000 to 65,000. We're involved with the part of the process of the facade around the outside of the southern stand there. Fletcher Construction won the contract for the Eden Park upgrade, and Cullum's Engineering from Whangarei, which is about 2 hours north of Auckland, won the contract to supply and install the South Stand Facade, which is basically looks like the birdcage from the Chinese Olympics, same kind of material. We're involved with Cullum's to fabricate 4 of the curved ferns there, full ferns, 6 half ferns and 2 bookends at each end of the stadium. So the fabrication was done in the Cullum's Engineering workshops in Whangarei. We worked with the staff of Cullum's Engineering to fabricate those different ferns. They were, once we'd fabricated them, they were sandblasted, painted, then trucked to Eden Park, approximately 200 kilometres away. Because of this trucking to get it to Eden Park, they had to be in a size that could be taken on the road, so there was a lot of bolted splices to accommodate that, to allow them to be able to be trucked to Auckland. The ferns were installed by Cullum staff on site at Eden Park, and then the Aussies arrived to install the cushions that we'll see a bit later on. So a few facts on just the structure itself. 6.5 kilometres of pipe, 1,727 welded assemblies. The bits that we're actually involved with were the curved structures, so 236 different members there. There's a picture there of the bolted splices there. There was 500 different bolted splices to allow the whole structure to be bolted together on site down there, so it could actually be trucked to Auckland. There's 400 of the cushions that make up the actual finished product on the outside, which looks like the birdcage from China. 5,745 Ts that actually have an aluminium extrusion. They're bolted to an aluminium extrusion is bolted to these Ts to actually hold those cushions in place. And each one of those Ts has 4 bolts to hold the extrusion onto it. So 23,000 bolts for the Australians to do up there. So it'll probably all fall to bits during the final. The weight of one of the full ferns is 8.3 tonnes, 12.5 metres wide, which obviously you can't transport that on our tin pot little roads, so they had to be able to be bolted together on site. So they were split in half. The lower half of the fern was split down the middle basically, so it could be, one half could be trucked. So that was fully welded on one side and the other half was bolted together. BDS, who were the steel detailers, 570 welded drawings, 974 single part drawings. Luckily we didn't have to really deal with too many of those. So our role in the process, we got the 3D data from BDS steel detailers, input that into 12D, had to change the models for the upper half and lower half of the fern because we had to rotate the lower half of each fern so we could actually set it out as it was being fabricated in the workshop. So luckily 12D had just brought in the 3D helmet transformation to allow us to rotate those lower halves of the fern so we could get them into the orientation that they'd be fabricated in the workshop. We uploaded the different data sets into Secure Robotic Total Station for Setout of fabrication using CFCE, I'm afraid. I didn't actually know about Field at the time that much and didn't actually support our instrument at that stage. So fabricated the ferns on site with Cullen's engineering to a required tolerance. It was very hard to get a tolerance out of the contract of what we had to actually work to. As far as the 3D tolerance was concerned, they were talking about tolerances of each steel member and things like that, but they didn't actually have a tolerance for a 3D structure. So basically, we made one up. So once we'd actually fabricated each portion of the fern, we downloaded the Setout data back into 12D and ran some verification checks on it to confirm all the points on the pipework were within the required tolerances, and verified that back to Cullen's engineering to confirm that the fern was ready to be processed further through to finalise it and take it to Auckland. Just a note there that we actually only surveyed them at tack welded stage. They were just tack welded with arc welders, and then they came along and tack welded them fully after that. So we never actually surveyed one after they were fully welded. The welding process does bend steel quite significantly, but they still went together, so obviously didn't do it too much. This is a bit of a visualisation. That's the three main pipes that we had to start with on the upper portion of the fern, and it shows how we built up the fern with the cross members across it. Basically, these things are hanging up in the sky above some scaffolding. They're pretty loose, as you could say, floating around in the air, held up on a few stands and things, which was all waving around in the breeze when you first put them up, until we actually put these cross members to actually firm the whole thing up. So this is the lower half of the fern, and obviously we didn't want to build it 12 metres up in the air, so that was actually rotated, so it was lying down on the workshop floor basically. But those rotations weren't a straight 90 degrees or anything, so that's where you use the 3D helmet to calculate those. And that's the full structure of a full fern there. How it was done. I met with Cullen's Engineering and Fletcher Construction and BD Steel detailers back in September 2008. At that stage it was decided that we needed to have 3 points on each pipe, obviously to give it a definition in 3D space, and we needed those on both sides of the pipe in case we couldn't actually see to those when we were surveying on one particular point. BDS spent many months, well, the model wasn't the big thing. I think the actual time-consuming process was actually producing all those plans that would allow Cullen's to actually construct it. So BDS supplied us with a DWG of the centre lines of each pipe and 3D coordinates just as a report of each of the survey points, and some very limited drawings that showed where those survey points were. We didn't have to use the 1500 drawings that Cullum's did, thankfully. So we mainly dealt with just 3D data. I've been over this bit, but yeah, the size of the ferns meant that the lower half of each fern couldn't be fabricated in the orientation it had been designed in, or it would be installed in, so it had to be rotated. 12E came in and great time with that for us, because it was about 2 days before we had to start the first fabrication on the first fern, so that was great. 236 curved pipes were rolled by Cullum's. Basically that's why they got the job, because they're the only engineering shop in the country with big enough rollers to roll these pipes. So each one of the rolled pipes was checked against the BDS shop assembly plans. Each of the joins, the EDS provided a wrap, so it was just a shape for the cutout of each end of each pipe. Then 500 splices were cut into where these bolted joints would be provided into the pipes as well. That slide there shows some of the T's. They're upside down there. You can't quite see the bolt holes, but that's where they're welded onto the actual pipes themselves. So each one of those had there's sheets of plans that show the correct location and rotation of those along the pipe. So once they actually built all the different components of the ferns, we were ready to fabricate those ferns. Cullum's stuff, the original one we did, obviously didn't believe how we were going to do it, so they did it conventionally. One of the BDS plans had chain edges and offsets and heights to each one of these survey points. So they set up a grid and measured up. This is the plumb bulbs they were using to drop down from the survey points. Then they used a level off the floor to get the Z value of them. Took them a fair while to set up the first one. This is a visualisation of the space frame, I suppose you could call it. The pillows fit in between these different pipes here. These are all basically up there now. It's just the bookends at each end. They're waiting on some other providers to install their works there before they can finish off putting up the bookends, but everything else is up there now, and the pillows are being installed. That probably gives you an idea of looks like I have to go right through. Just about done. I thought I could stop this. Okay, just speed it up. In the workshop we did a 3D resection to position the instrument, obviously, get ourselves in terms of where where they put the main pipes. We surveyed the central pipe to make sure it was in the correct position within very tight tolerances, because it was all based on getting that one, the main thread, in the correct position. We then installed the cross pipes to firm up the whole structure. So basically, on site where we were working with left, right, in, out and up, down, and we'd have to position the 3 different points on each pipe to within the tolerance to get each one in the right place. So the main pipes had four survey points along them, because there was a straight section and then an arc. So the arc had 3 points and another point for the other end of the straight. Each of the pipes had to obviously fit well enough with the other pipe that it could be welded, so you couldn't have a big 10mm gap around it that couldn't be welded, and it couldn't push the other ones out of place. Positioning the pipes could go quite easily or take forever, just depending on how they worked in with the other pipes. And as you can see from some of the further slides through, that some of these things were 30 metres away and 8 metres up in the air. Grinders, welders, noise everywhere, so not an easy place to work. So after the pipe was positioned, it was spot welded, and then we checked it, and all that data was recorded into the SRX for later download into 12D. So there's Max Burgess there holding the prism that we're shooting to one of the survey points there, lining up one of the pipes. So each of these fabrication processes took about 2 days for the upper and lower portion of the fern. And because of that time frame, we had to keep going back and checking the existing pipes to make sure they're still in the right place. So we downloaded the SRX data, used survey reduction function to reduce it and check it, compared our as-built and check shots to our 3D design with the record here. And then we actually had to look at the 3D data and not just 2D data to confirm that it was within the tolerance. We had to make sure that we obviously had the three points on every pipe. Yeah, so I'm asking for a 3D distance QA report instead of the 2D one that we've got at the moment. And while I was listening to Lane snoring this morning and farting and burping, I thought, after watching all these visualisations of pipe networks and things, that'd be a great way to actually display the difference between design and as-built as an exaggerated scale of the difference between design and as-built. So I'll talk to you about that. So once we confirmed that all the points were within tolerance, we gave a report and plan back to Collins Engineering for their QA purposes. So this is some of the bits under construction. We can see the arc and the straight there of the pipe lying on the floor. These are the splices with the 3 bolts there. And these are the cuts that were put on the end of each pipe with the wraps that they wrapped around the pipe. You can see the yellow circle, white circles on the pipe there that mark out where they put the wrap on. The top, well, probably the best to start at the bottom left there, that's the 3 main rails of the full fern. That's the upper portion of the fern. The top left there is putting one of the cross members into position. So you're working with cranes and things to try and hold them in place and getting big hammers out sometimes to make them fit. The central one there is how they line up every single one of those 5,700 T's with, just by angle off the level up their pipes, and then just set them out by angle there. It's just one of the guys welding up one of the members there. This is a top half of a foot fern going from Whangarei, and it's just going into Eden Park here, 4 o'clock in the morning. Being lifted up by the crane, 6 o'clock, got off the truck, and by 8:15 it's in place. So they were very happy with how it went together. That's the end.